Hi and welcome back to my channel. In the last video, I showed you how you can send emails in the background using a queue and a background worker service. This is how it worked. You could send a message here, you could write a message. This is my message. And then I send. Then I used a queue to queue the message. And I had a background worker service to read the messages from that queue and send them. Even though sending each email took 2 seconds, you get redirected to the new page instantly. So that was the advantage of this pattern, this model of project coding. And it's all good, but the problem is it works in process. You have to use background worker in the same process as your main application, because this queue is only in memory, and if you close the application or shut down your web application, the queue disappears, and there is not much flexibility to it. So today we want to change our tools and use RabbitMQ and do the same thing, but in an inter-process model. I have already installed RabbitMQ and I am using Docker for that purpose. If you search the web, there are a lot of sources that shows you how you can install RabbitMQ. Using Docker is pretty easy. It comes with RabbitMQ management control, and you can have this username, password, guest, and guest to log in, and then you are ready to go. And I'm not going into how you should install RabbitMQ. I think there are plenty sources for that, but today we are going to have our web application send messages to a queue inside RabbitMQ. So first of all, I need to install RabbitMQ client, and to do that I use manage NuGet packages. I go to browse and search for Rabbit, and the first one is RabbitMQ client with more than 90 million downloads. This is what we want. Obviously you can use other tools like mass transit and service and other libraries, but I prefer the raw version, at least for simple applications. So we have the client installed. Then I can go to my page here, and let's remove the queue or task job. You can move the injection and get rid of it altogether. And you don't need to inject any service. You can directly instantiate the RabbitMQ client object. First though, we need a factory to create a connection. So let's name your variable as factory, and new connection factory is what we want. We want to go with default values, and connection factory lets us do that. Everything is default. You are connecting to localhost, guest user, and it works perfectly fine with our demo application. But if you need to configure the port, the address, and user password, you can do it here. All kinds of settings that you can set up right here. So let's keep it simple for now and go for connection. Now we need to have a connection, and as you see, Visual Studio is suggesting the code to me that you are creating a function, factory create connection. That's all I needed exactly. And then I need a channel, and is to go through creating new connection. Go through connection, connection here, and create model is what we want. We want to create the channel. That's the first step. So create a factory, create a connection with that factory, and channel inside that connection. So a connection can have multiple channels. It's like gateway or a highway with multiple bands working. You can use to send messages at the same time. Next, we need to declare an exchange. And to do that, I use channel and channel exchange declare is what I call. Then I use exchange. My exchange would be email box. Email box, and let's see if we need to add more. Yes, we need to add the type for our exchange, because in RabbitMQ you can have different exchange types. So I search for exchange type and go for direct. It's the easiest one to work with, and pretty much usually you end up using direct messaging. Unless you are working in a microservice environment with many applications. So we have our exchange, then we need a queue. So to use a queue, you need an exchange. Messages go to exchanges first, and exchanges distribute them to queues based on bindings. So first we need a exchange, then we need a queue declare, and the name of the queue would be email send, and there are some options that I can set. I set all of them to false. It's just easier to demonstrate, and you don't need anything else. So then we need to bind this queue to this exchange. You don't have to always create bindings. By default, RabbitMQ does that sometimes for you, especially if you are using direct messaging. But I like to explicitly define bindings myself, so I know what is happening. And in this demo, that's exactly what I'm doing. So let's do queue bind, and now we need a queue, an exchange, and a routing key. And so our queue is email send, and the exchange is email box, and the routing key for me it would be email address. Routing key is just the same as a routing in your control. It's kind of the same. It decides what message should go to which queue based on which exchange. In more complex scenarios, it helps a lot. But in direct messaging, there is not much use to binding, because you have one exchange, you have one queue, and you just want to work with that. But in other exchange types like fan out and headers and topics, binding is necessary. So we have the basis for our connection to RabbitMQ, and now we can send a message to RabbitMQ using channel basic publish, and here you can exchange which exchange you want to send your message to. It would be email box, and then routing key. I'm sending email address to this, and then we also need to have basic properties, which property we are going to send. For us at the moment, we don't have any specific properties for sending this message, but we want to send a specific content that is the body of our message. So the body is a byte array. So first we need to convert this message that we are receiving from the web form to a byte. Then we can send them to our RabbitMQ instance. So let's have a class, public class or private class. We don't need the public class, we need a class. Let's call it email, and let's have a property type of a string, and message would be the property. You don't need hot reload at this point. So yeah, let's have an email and have new email, and here I can set the message. So I'm passing message from here to this object here, and then I need to convert this to JSON and convert JSON to byte array, so I can send it through RabbitMQ and read it later. So let's name it JSON and use system.text JSON serializer and serialize email. So we have our JSON, then we need the body is in byte. So let's use system text encoding and UTF-8 and get bytes from JSON, and now I can send the body. That's all you need to send a message to a queue using direct exchange in RabbitMQ. Now let's try and send messages to our RabbitMQ instance. Here I have my application loaded, and this is next message and send. So let's see RabbitMQ management. Now we have channels. We are connected and channels are created. We have an exchange email box, the same as the same that I said here, and we have queues. Email send queue. It has two messages because this hot reload works in background, and immediately when I save my file, it refreshed this page and send a message, and then I started the application and sending another message. So we have two messages in the queue, and if you check the queue, you can see the bindings. There's a binding email box that binds exchange to the queue, and that's it for now. We have our messages in a queue. Next, we need to read these messages from the queue, and that's where a background worker saves come to play. So I don't want to use an in-process worker service. I want to have a completely separate project. So I go to new project and use worker service and name it email worker, and put it here in test. Let's enable Docker, and we use it later, and that's it. That's all we need for now. So We have our background worker. We don't need this loop, so I remove this. And let's add RabbitMQ client again. So that is the same thing. I search for RabbitMQ and I add the client to my project, and I need the same thing here. I need this factory connection and channel, and I put them right in here. Of course, you can refactor the code and separate the methods, create a class, inject it, all kinds of things. But for me, at this demo project, I prefer to have everything in the same page so you could understand how it's actually working. And you have a factory, channel, connection and channel. And we need a consumer. And we want to consume messages from a queue, so we need a consumer. So I implement the consumer, and it is eventing consumer. I'm not sure if I can remember the word. Eventing. Let's search it on the web. So I think it's eventing basic consumer. Yes, I always forget the word eventing basic consumer. And let's add the using, and this is our consumer, and the consumer needs to be instantiated. Also needs a model. A model would be the channel for us. And consumer receives messages. So we want to react to received event with plus equals sign, and I can use model and E here and have a lambda expression and anonymous function here. And we have our event arguments, and we can read the body of the message in bytes. So e dot body would be the body, and JSON would be system text encoding, and UTF-8 get a string, and the body is what we want, but body is not an array directly. It is a memory read-only memory, so we can convert it to array first. And now we have a JSON, and let's then convert it to our object, the object that I created here. Let's copy and paste the same object to a different project. I don't like to share and connect the project to get each other directly, because we are trying to have a microservices pattern here to separate projects as much as we can. And we have an email class here, so I can have email. Email is deserialized from JSON. So let's use system text JSON and serializer, JSON serializer, and deserialize to email JSON. That's great. That's exactly what I needed, and thankfully Visual Studio generated that code for me. And now I can go ahead and use logger and log information and say email sending to this, and let's have message email here. I need a message. Also, yeah, we can stimulate sending messages. Then we have to copy and paste the mechanic that send messages uh, in the web project. But it's all a demo, so to show you what I mean. Here I just had email send with a delay to simulate sending emails. I'm not actually sending emails, but you get the idea. So we have a receiver, consumer that receives messages, and now we need to consume the messages. We use the channel and the basic consume to consume messages. We need to set a queue. What is the queue that we are using? The name. Of course, in a serious project, you need to read them from static to constant or something. But for this demo project, this is the way to go. And at this point, I don't like to do an auto acknowledgement because I'm going to test the queue for a while. But I need the consumer, and the consumer is set here. So we start consuming messages, and that's all we need. So let's set this as a startup project and start debugging. And hopefully we get the messages that I'm not sure. This is running Docker in the background. Maybe I don't want that. At this point, I just want to use default. It was quick. So the email worker is at work, and as you can see, we are reading the messages from RabbitMQ, and in RabbitMQ management, change from ready to unacknowledged messages. And so we read the messages and we have them. And let's see. Let's acknowledge them, auto acknowledge them, and empty the queue when we read them. So to do that, let's close all these instances and go to this worker that we just created, and let's put it through. You can acknowledge messages one by one, but it's the easier implementation here. Depends on what you need. We are sending messages in a fire and forget pattern, so I don't really care about the actual data. Just do the act, and if it works, it works, and if it doesn't, it doesn't. But sometimes it is serious and you want to be exact about each message and which one are read, which ones are acted upon, and that's when acknowledgement comes into play. But for now, for this demo project, we set it aside. And now let's try the project again. Let's run it again, and receive the messages again. But this time, if you check the management, you don't see any messages remaining because you read a message from the queue and you dequeue it. You remove it from the list and you continue. So I can run both applications at the same time and keep sending messages from the first application, and the messages would go to my RabbitMQ to this queue, and then I can read it later or directly as soon as they come. And the asynchronous nature of this system helps with a lot of problems that we have on the web, because you don't have to be real time. You send a message, you put what you need into a queue, into a basket, and later some service reads that queue and acts upon it. So it's it is a bit more complex to implement, but it solves a lot of problems that we have in distributed applications. That's my demo for today. Thanks for watching and see you soon. Please like, share and subscribe, comment if you like to.